Okay, so for this topic, the tables of integrals, you're going to need the file of the table on our Blackboard page. This is at the end of your textbook. You can have it there. However, if you have the paperback edition, it seems that half of it got chopped off. So I have posted the full PDF on our Google Drive. So go check that out so that you have it as reference and stash it in your notebook. So what the table of integrals is for is to kind of simplify and speed up the process of integration. It would not make any sense to you if you had not learned how to integrate to begin with. But now that you've been integrating for a while and done a lot of problems, you'll see that there are some archetypes, as we say, that kind of arise, and some patterns that, all right, this looks exactly the same as the one I did before, except it's got a 3 instead of a 4 on it, right? So what it does is gives you a kind of breakdown on how integrals of this structure should go. So the first example here, the integral of x cubed times e to the 2x. What I would do is go to my table here and look for an integral that fits this description. So they're broken up by headings here. So products of e, cosine, sine is number 2. We don't want that. Look for product of polynomial with ln e to x. Here we go. So here's number 14. Polynomial, a monomial counts as a polynomial, times e to the ax. What should this look like? Well, it looks like 1 over a to whatever the power of inside e is, p to the x times e to the a of x, and then minus 1 over a integral p prime e to the ax. So it takes care of that integration by parts for us. We don't have to choose the u and dv. This table has it kind of figured out already. So we'll head back and look at this guy here. So this should be from number 14 table. And I'd like you to cite which one in the table you use if you're working this out on an assessment. Would be 1 over a, so that's 1 over 2, p of x, so that's x cubed, e to the 2x, minus 1 over a, 1/2, integral p prime of x. So what's the derivative of p of x? That's 3x squared, times e to the ax, e to the 2x dx. Right? And so we see that this isn't quite done, right, since this power was larger. And so we can actually go to the second line on this table, right, where it has this alternating sign all the way down until your derivative is 0, which is what happens when we integrate a product of a power function times e to the ax. So we're going to use that to continue this line. This should really be 1/2 x cubed e to the 2x minus 1 over a squared, so that's 1 over 4, p prime of x, so that's 3x squared e to the 2x, plus 1 over a cubed, so 1/8, second derivative of p, which is 6x times e to the ax, and then minus, these signs alternate back and forth, for the last one where we see we've just got 6 over 8 e to the 2x. And then after that, what's going to happen? The derivative of this term will be 0, and so the pattern stops. So we have the full integral. And we need a plus c on that guy. And then just kind of tighten up the scalars here, and you are good to go. Minus 3/4 x squared e to the 2x plus 3/4 x e to the 2x minus 3/4 e to the 2x. Now you might want to think about factoring out an e to the 2x to make that look nicer, but this is good as is. Okay, so it's number 14 in the table. Let's do one more here. look at, this is a big book. There we go. Let's do one we can't do by hand. Okay, perfect. Number 18. This would be a pain to do by hand. Possible, but not fun. So what we'll do is we'll look at the table for products of sine and cosine. And so we see that right here. Number 10 in the table is a product of sine and sine, where A and B, those frequencies are different, and that's a key component of using this part of the table. You'll note at the end it says A cannot be equal to B, and so it gives us straight out the integral right from there. So what this should be where A is 3 and B is 5, and again this is number 10 in the table. So it should be 1 over b squared minus a squared, so 25 minus 9, all times a cos ax. So if a is 3, so 3 cos 3x times sine of bx, so sine of 5x, minus 3 sine 3x times cos of bx, so cos of 5x, all plus c. And obviously you can just simplify this piece to 1/16 times all of that. Alright, let's do one more. And that will be number 21. So 21 is the integral of e to the 3x, e to the 5x, sine 3x. So what do we have? We have a product of e and sine. Look at that, number 8, right there. So we'll use number 8. Number 8 in the table, where we know that A is 5, B is 3. Alright, so these parameters are what dictates how the integral will go. And then from there we get, alright, what is it? 1 over a squared plus b squared, so 1 over 9 plus 25, times e to the ax, times a sine bx, so 5 sine 3x, minus b cos bx, so minus 3 cos 3x, all plus c. And that's good to go, right? This is really just 1/34 times all of that. Excellent. So, using the table, pretty easy, but you have to keep track of these little arguments, these little parameters in here, because it can easily get mixed up. And it really wouldn't make any sense if you didn't understand kind of what the point of this was. And the point is really to shorten the amount of time we have to spend on integration by parts, because a lot of them seem to have the same exact format. So have fun with these practice problems. Again, the file for the table is online. Hopefully you had that with you. Otherwise this would be probably a tremendous waste of time. And yeah, hit me up with questions.